Hello everyone, welcome back to MGF1106. So the first time when we start this chapter, I say that the purpose of logic is for you to obtain the skill of reasoning and make a convincing argument. When I say convincing argument, I means that the argument that is valid. So in this section, section 3.5 over here, I would like to discuss what symbolic argument is and how we create the valid argument and what's the difference between a valid and invalid argument. And at the end, I will introduce some standard form of valid argument and invalid argument. Okay, so let's get started. Section 3.5. Symbolic argument. Okay, so first of all, on the first part right here, let's discuss the definition of argument. What is argument? Argument is actually a collection of statements. Okay, and we can draw conclusion from this collection of statement. Okay, and if the conclusion is true, well, you remember we talked about the truth table, right? When we said when we have all value is true, then we know it's tautology. So if the final true false column is true, is tautology, then we know that that argument is valid. Okay. Now let me go ahead and start with the definition first, then I'll give you example. Then I will show you that in the example I have a whole column of true value. Then I can conclude that the argument is valid. Okay. So first of all, I'm gonna put the definition in here. Argument. Okay. Argument is just a set of statement, to the a set of statement. Okay, which we can draw conclusion from. Okay, and if conclusion okay, if conclusion is true, then we have valid argument. So if the conclusion is not true, then we have invalid argument. In that case, we will call the fallacy. So if conclusion is not true, then we have invalid argument, which is called fallacy. Okay. Now let's jump to the first example here. In the first example, I will give you a collection of statement, which is the argument, and we're going to use the true-false table to check if the final conclusion is it has true value or not. Okay, if it is true value, it means that we have tautology. It means the argument is valid. Okay, so let's jump to the first example here. Okay. Alright. Alright. So I have the problem like this. So I have I said over here, use the truth table to determine whether the following argument is valid or invalid. They give us the statement like this: the United States must energetically support the environment of solar power car or suffer the increasing atmospheric pollution. That is the first premise. So this is the first premise. Okay, this is a premise. Right over here. Right over here is the first premise. Okay. Okay. So I'm gonna put over here. This is this premise. Okay, premise. First premise. United States must not suffer the increase in atmosphere. So this is the second premise. Okay. Okay. Then right over here, the whole thing over there under the bar right here. This is conclusion. Okay. So we have, you see that we have statement right here. We have another statement, and at the end we have another statement. So this is argument. This is argument over here, the collection of statements. So it's the first statement over here. We call it premise, and this we call this the second premise, and finally we have a conclusion. And we see that we want to check if this argument over here is valid or invalid. Okay. So first of all, we need to get the symbolic form first. Okay, we need to get a symbolic form, and so let's see what it look like. So we know that this is or, so this is the disjunction statement over here. So the first premise is the disjunction statement. So I'm going to call this P right here. P represent United States must support the development of solar power car. Okay, US must. I'm going to just write it shortly. Okay, support the development of solar power car. Okay. Then we have Q. United States suffer increased atmosphere pollution. Suffer increasing atmosphere pollution. Okay. So we have two simple statements here, and at the end, we have actually we have P again, right? So we have P again. So we have only two. We have only two simple statements over here. Now I'm gonna go ahead and create a symbolic argument here. So the symbolic argument we can get for this is that so this is R. So we got a P or Q. Okay. Then that's for the first premise. The second premise is a negation of Q. Okay. Negation of Q. Okay. Okay, negation of Q. Then we draw the bar. Then we write three dot like this. Three dot, it means therefore. Okay, so this part right here is mean therefore. So this is mean therefore. Okay, so therefore what? Therefore you must introduce. So therefore P, right? Therefore P. So this is P. Okay. Okay, so this is a symbolic argument right here. So the whole thing right here is symbolic argument. Okay, now we're gonna go ahead and check. Okay, we gotta go ahead and check if this symbolic argument is valid or not. So we have to create the truth table, and we already know how to create the truth table last time. Okay, we create a truth table. Okay, so we will have over here, we have P, Q, then we have negating of Q, all right, negating of Q, then we want to do conjunction. Let me see, it's true or not. We gotta do conjunction. We gotta do P. Yes, P. Gotta do P disjunction first. P because it's or, so we're gonna do that one. Q. Okay. Okay. Then let's see what else. This one. This. Then we gotta see. We gotta do conjunction for the first two, for premise 1 and premise 2. Okay, so premise 1 is this, so we gotta do conjunction. Okay, conjunction between premise 1 and premise 2, so we gotta do this one. Then finally we gotta do a conditional statement. Okay, we gotta do conditional statement. Okay, so the conditional statement to get the conclusion, so this is conclusion over here. It means that we're gonna take this part over here, okay, and we draw the arrow. I'm sorry, this should be the negation. I'm sorry, so let me delete this. So it should be the negation of Q. Look like I don't have enough sound. You know what? I think I'm gonna make this a little bit bigger. So let me erase everything, and because I look like I don't have enough space right here, let me erase everything here. Okay. Let's make it bigger a little bit. Here you go, something like that, so that we can easy to write everything in. Okay, so we have P, Q, then we have negation of Q, then we have P or Q. Then we find the conjunction between the first premise. That is very important. That the one right over here, the conjunction, first premise, and the second premise. Okay. Then finally we have the conditional statement. A conditional statement is actually this. So this is conditional statement right here. So conditional statement is the antecedent. It will be, so the antecedent will be P for Q intersect with negation of Q, okay, imply P. Okay, so that is conditional statement we need to do, and I call this conditional statement over here is C. So I'm gonna put C over here. So I have to check C. Okay, so this conditional statement. If the C column over here it turned out to be true, it means tautology, then the whole argument is valid. Okay. So I recommend that after you write a symbolic argument, make sure that you also write a conditional statement for this argument, because without a conditional statement, then we don't know what we put on the truth table, right? It's very important. Okay, so let's get started here for the truth table here. So this one will be true true. Again, it's true true, true for true, and for. So we want to negate the Q, so it become for true. Then you find the union, the or mean, you remember the example I give you, example that have the bachelor degree or 5-year experience, 6-year experience. So P and Q, so they have both over here. So this will be true for will be true because they just need one. They don't have bachelor, but they have experience, so it will be true. And they don't have bachelor degree, they don't have experience, so it will be for. Okay. Then we find intersection between these two. So intersection between these two. So the intersection between this and this. So intersection could be so this is deliver TV, but this does not deliver laptop, so it would be for. Deliver both would be true. Deliver TV but not deliver laptop would be for. Does not deliver TV but deliver laptop is still for. Okay. And now we're gonna do conditional statement. So this imply this. This imply this. So for implies true. Remember the example again. Example I give you. If you pass the class, right? Then I promise to buy you a watch. Okay. So you don't pass the class, but I still give you a watch. The promise keeps, so it will be true. Okay. We use different color. It'll be true. You pass the class, I give you the watch, that will be true. Okay. You don't pass the class, I don't give you the watch, will be also true. And I know you don't pass the class, and this is I still give you the watch, so I don't give you the watch, that's true. So right over here is tautology, right? Is tautology. So over here, if we have a conditional statement as a tautology, then we can conclude that, okay, we can conclude the argument is valid, okay, because the conditional statement over here is tautology. Okay. So you see that in this first video we have two simple statements. We have two premises, but we have only two simple statements. Okay. Now in the second example, I will give you the case when we have three simple statements. Okay. I have something like this. Okay, how about something like this? Okay. You choose to determine whether the following argument is valid or invalid. So you see over here, I have the first premise over here. So this is the first premise. Then we have the second premise here. Then we have over here we have conclusion. Based on this, we can get a symbolic argument. But you have to define the simple statement first. So answer. So the first simple statement over here that you lower the fat in your diet. I have to say sorry because sometimes I have very bad allergy and I cough during the lecture. So be patient with me, okay? Then the second statement is you lower your cholesterol. Okay. Then the third one, you see that we have another simple statement right here. You reduce the risk of heart disease. Okay. Okay, so let's see how we're gonna go ahead and create the symbolic argument here. So the first parameter is actually the conditional statement, right? So P imply a Q right here. Then we also have another conditional statement. If you lower your cholesterol, so you have Q imply R. Okay. And therefore, so we have three dots. If you do not lower the fat in your diet, you do not reduce the heart attack. Okay, so we will have do not lower the fat, so it will be negating of P, negating the risk, negating R. Okay, then I'm gonna go ahead and write a conditional statement for this whole argument over here, so that we can write. We know that what we put on the true/false table. So first of all, we're gonna take the first premise. So P imply Q. We do conjunction with Q imply R. Then everything over here we do by do conditional statement with this one over here, the conclusion. Negating of P imply negating of R. Okay, so you see that how complicated we have for this true-false table, right? That should be a pretty big one right there. Okay. Okay, so let's see. I have enough space to put the whole table. I thought I should put this conditional statement up here so that I have enough space. Let me see. I can do that. Oops. Let's see. Okay. So I just cut it. And right over here. Oops. I cannot paste it. Oh my god. Oh, I don't know how to paste it. And let me see, I can paste it from here now. How I'm gonna paste it? I think I just lost it. I have to write it again now. Yeah, I just lost it. Ooh, that's bad. Um, oh my god, I don't know. I just lost it. I guess I have to rewrite it. I don't know how to use that tool. Um, I'll figure it out later. So let me write the conditional statement again for this argument right here. So I have P imply Q. Then we do conjunction. Q imply R. Then imply negative P imply negative R. Okay. Now let's go ahead and load the true false table. Okay. So I'm gonna have P Q R. Then we have P imply Q, Q imply R. Then we have a conjunction. Oh man, this is like we need to have, or we don't have enough information. We don't have enough column over here. Then we have negation of P. Then negation of R. Sorry, I don't have enough columns, so I guess I have to divide this column into half. Okay. Then we have negation of P implied negation of R. Then finally we have the last column, which is the final conditional statement. So I have to write over here because it looks like that we don't have enough column right here. So I have to move this a little bit higher. Okay. 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 So let's do it. So we have two four, 2 for 2, 4 2 2, 2 for 4, 4 2 4, 4 for 2, and 4 4 4. There you go. So we have 8 arrangement right here. P imply Q, P imply Q. So you pass the course. I promise to give you the watch. So this one, it look like that we will have you pass the course. I promise to give you the watch. There's 2. Pass the course is watch 2. You passed the course, but I did not give you the watch. Promise broken 4. You don't pass the course, but they still give you the watch. Promise keep 2. This is 4. This is 2. You don't pass the course. I don't give you the watch. This is true. This is true. Okay. Now with the Q imply R. So this is true. You don't pass. You pass the course, but I don't give you the watch. So this is 4. You don't pass the course, so I still give you the watch. It's true. It's true. You don't pass the course, I don't give you the watch. It's true. You pass the course, but I don't give you the watch. It's 4. You don't pass the course, I still give you the watch. It's true. You don't pass the course, I don't give you the watch. It's true. Okay. Then we're gonna do conjunction. We're gonna do conjunction. Okay. Between this and this. So let's see. This one is gonna end up with what? Conjunction gonna be laptop, TV, laptop, TV, laptop, believer. So this true. For, true, for, true. Now negation of P, which is this one. Negation of P will be for, true, for, true. Negation of R, for, true, for, true, for, true. Okay. Then negating of P imply negating of R. So this one I'm gonna give you what? This is you don't pass the course. I don't give you the watch. True. You don't pass the course, still give you the watch. True. True. You don't pass the course. You pass the course. You go to 64. This is true. You don't pass. You pass the course, but I don't give you the watch. For. This is true. Okay. Now we're gonna do do conditional statement for between the purple and the blue right here in order to get the red color. So you pass the course, I give you the watch. True. You don't pass the course, I still give you the watch. True. You pass this, you watch. True. You don't pass the course, you pass the course, but I don't give you the watch. This for. True. You pass the course, I give you the watch. For. This is true. So you see that the final true false column right here is not tautology. Because it's not tautology, so I can conclude that argument is not valid. There you go. Okay. Pretty easy, right? Now I'm gonna, on the second part of the video, the second Roman, I'm gonna provide you some standard form of valid argument and invalid argument that you usually see when you're doing homework. If you don't see this argument, then you have to create the true false table in order to determine if the argument is valid or not. Okay. So the second Roman. Okay, standard form of argument. Okay, standard form of argument. Now let's talk about valid argument first. Okay, number one, valid argument. So we have totally let's see how many valid argument we have. We have totally four different valid argument over here, and it depends on some textbook. They have different names, but I'm going to provide you all different names so that maybe you read another textbook, you recognize it. The first valid argument, the first valid argument here, we call it direct reasoning. Direct reasoning. Okay. And in some textbook, we call that law of detachment. Law of detachment. Okay. And this is what it looks like. You have P imply Q. That's the first premise. And the second premise is P. Therefore, you have Q. Okay. So if your argument is in this form, then you can jump to the conclusion right away. This is valid argument. Okay. So that is direct reasoning. The second valid argument, we call that contrapositive reasoning. Contrapositive reasoning. And this one, we call that law of contraposition. Law of contraposition. Okay. So the law of contraposition goes like this. You have P imply Q. Okay. Then the second premise, we have the negation of Q. Therefore, we have negation of P. Okay. So if we see the argument in this form, you can jump into the conclusion right away. That argument is valid. Okay. You don't need to use the true false table. You don't have to. Okay. You can, but you don't have to. It's this light faster way. Okay. And the third valid argument is called this is called transitive reasoning. Transitive reasoning. Okay, in some textbook, oops, I got some same problem right over here. And last time I have this problem too. I don't know how. Okay, it worked now. I don't know why. Reasoning. So this transitive reasoning. Okay. Oh, look like it's delete my writing. So let me redo it. So P imply Q. Okay. Okay. I don't know why my pen is like that. It's really weird. I hit something, but I don't know what did I do over here. I don't know what I did over here. So it just turned out to be erased everything. It's just that's weird. Okay, so the transitive reasoning, we have another name. We call that the law of syllogism. Okay, law of I don't know, actually. I don't know how to pronounce this word right here. And this is the first time I use this word, because this actually our textbook used this, because before I use this textbook, they call it transitive reasoning. Syllogism. This is the first time I used this term right here. The first time I seen this word. Okay, so this is called the law of syllogism. Okay, and it go like this. If you have P imply Q and Q imply R, then you have P imply R. There you go. Then finally, finally we have disjunctive reasoning. Disjunctive reasoning, and we can call this disjunctive syllogism. Okay, syllogism. Okay, and it go like this. If you have this disjunctive, right? So you have P or Q, and you do negation of P. Then at the end, therefore, we have Q. Okay. Again, I recognize you memorize all of this valid argument is faster. But however, disjunctive reasoning has another form. Okay. Another form goes that if you have P union Q, and you do negation of Q, then at the end you have P. Okay, so you can take negation of P, then you end up with this, with the second one, with the second um, statement here, or you take the negation of the second statement, give you the first statement. Okay, so disjunctive reasoning have two forms. Okay, so that is the valid argument. Oh, sure, that erased this too. Oh my gosh. Second Roman standard headed. Okay. Now, the second form of argument is the invalid one. So number two is invalid argument. And I have some invalid argument right here. I have totally 4 invalid argument. The first invalid argument, we call that a fallacy of the converse. Okay, fallacy of converse. Okay, this one doesn't have another name. So the fallacy of the converse go like this. If you have P imply Q, and you have the second premise is Q, therefore you have the first premise, then you have P, then you have P. Okay, so this is the fallacy. Okay, so this argument over here is not valid. Okay, another invalid argument is called the fallacy of inverse. Fallacy of inverse. So you have P imply Q, and you have negation of P. Negation of P. Then you can imply therefore you have the negation of Q. So this is not true also. Okay, this argument is not good. Okay, so we don't have this. Besides, we also have another invalid argument. We call that the fallacy of disjunctive reasoning. Sometimes we sometimes we call the misuse of disjunctive reasoning. And remember last time we have disjunctive reasoning. We have two forms. Okay, so I mean over here we have two forms of invalid argument. The first form is you have P union Q, and then you have P then you have a negation of Q. And the second formula, if you have P union Q, then you have Q, then you have negation of P. Okay, if it is in this form, that's fallacy of disjunctive reasoning. So it is the argument invalid. Okay, then finally we have fallacy of transitive reasoning. Okay, transitive reasoning fallacy to go like it. You have P imply Q and Q imply R, but instead of having P imply R, you will have R imply P. Okay, so the valid argument is P imply R, but if you have R imply P, then that's a fallacy. Or sometimes you have instead of P imply R, you have negative P imply negative R. Okay, so if you see it in this form, you know, right, or this or this. Okay, then you know that the fallacy transitive reasoning. Okay, now we're gonna use this valid invalid argument here to determine if the argument is valid or invalid directly. Let me jump into the first example right away. Example number 1. Okay, example number 1. Okay, let's load it. Okay, so I have example 1 like this. Okay. All right, determine whether each argument is valid or invalid. So we have three arguments over here. So this first of all, we need to convert into symbolic argument first and see which one it look like the one we already have over here. Okay, if it look like the one we have it over here, then we know it's valid or invalid right away. If it is not, we gotta use the true false table. Okay. All right, so let's do it. Answer. Okay, let's do the first argument first. So the emergence of democracy is the cause for the hope of all environment problem will overshadow any promise of future. So look like that we have or also we have disjunction right over here. Okay, we have disjunction statement over here. So let's call P is the emergency of democracy is a cause for hope. Okay, then Q environment to problem will overshadow any promise of bright future. Will overshadow any promise of bright future. Let's check if the conclusion is kind of the same. If sometimes we have the third simple statement. Okay, so this is not, so this is negation over here. So so we look like we have only two simple statement. Okay, so from here we can write the first premise, P imply Q. Environment probably will not overshadow. So look like we have negating Q over here. Therefore, okay, the image is correct. So negating Q give you P. Okay, So let's see what it looks like. You have P, Q, negating Q give you P. Okay, so P, Q, negating Q. Oh, P, Q. Oh, I'm sorry. I think I have a mistake over here. So it's not a conditional statement right here. I'm sorry. So this is OR. So P disjunction. So P disjunction. Okay, so P disjunction Q. Negating of Q give you P. Okay, so look like this. Let's look like this, right? P disjunction Q. Negating of Q. Negating Q give you P. So look like this is valid. Okay, this is valid. Valid. Okay. Pretty easy, right? Very easy. Now part B. Oh my god, I have this again. Okay. Part B. Look like I have to double click then it's gone. If the defendant of DNA is found in the crime scene, then we have him stand trial. He stand trial. Okay. So look like P over here. Defendant DNA is found at the crime scene. Okay, and Q we have him stand trial. Okay, and this he says stand in trial. Here so there's only two simple statements over here. So now we can write a symbolic argument. So P imply Q if and then. Then we have his stand trial. So look like we have P imply Q. We have Q. Then therefore we found evidence of crime scenes. Okay, so look like therefore we have P. So P imply Q. P imply Q. Q give you P. I don't think we have something like that. So P imply Q. P give you Q. Or imply Q give you. Imply Q give you imply P. We don't have such thing as P imply Q. Q therefore P. So this is invalid because we don't have that. Okay. It's invalid. Oh, actually, this is invalid because I think it's come from here right here. See that? P imply Q. Q give you P. It's a fallacy of the converse. You see? P imply Q. Q give you P. This is invalid because it's a fallacy of converse. It's a fallacy of converse right here. Okay. So now part C. If you mess up, your self-esteem goes down. If your self-esteem goes down, everything falls apart. Okay. So P is you mess up. You know, when you get used to it already, you don't need to write P and Q. Q is self-esteem goes down. Your self-esteem goes down. Then finally we have everything's else fall apart. So look like we have three simple statements. Everything falls apart. Okay. So P imply Q. Q imply R. Right. Q imply R. So if you mess up, everything is fell apart. So look like we have P imply R. So this is transitive reasoning. So this is valid, definitely. Okay, it's valid. Okay, pretty easy. Very easy. Okay, now how about example number 2? Let's do another example. I'm sure that example number 2 we have more things to do. Example number 2. Okay, determining whether the following argument is valid or not. If people are good, law are not needed to prevent wrongdoing. If people are not good, law will not succeed in prevent wrongdoing. Okay, therefore law are not needed to prevent wrongdoing, or law will not succeed in preventing wrongdoing. Oh, this look like that. It's kind of complicated over here. Okay, let's see. Let's try to create the symbolic symbol first and see if it falls into what the standard form or not. If not, we figure it out. Okay. So answer. So we have P. People are good. People are good. Q. Law needed. Law are needed. We have a negating right here to prevent wrongdoing. Okay. If people are not good, look like this negating of Q. Law will not succeed in preventing wrongdoing. And therefore law not needed to prevent wrongdoing, or law will not succeed. So look like we have 3 of them. So look like we have R. Laws will succeed in preventing wrongdoing. Okay, so we have look like we have 3 of them. Okay, now we're gonna go ahead and create the symbolic argument. So we have Q imply negation of P implies, so this is P, I'm sorry, P imply negation of Q. Then negation of P were not good, negation of P imply negation of R. And then finally we have therefore law not needed. No, this will look like negation of Q, or law will not succeed negation of R. Jeez. Okay. So look like that. I have to say that we don't have any argument like this in the standard form. Yeah, we don't have anything like this. I guess that we can use I have to use the true false table over here. It look like that this is it's not even transitive reasoning, because this is all. So we don't have something. So that could be a long problem right over here, because we have to create a conditional statement for this argument first. Okay, let's create the conditional statement for this argument. So we're gonna have P imply negation of Q intersect negation of P imply negation of R, and everything imply negation of Q union or will not show negation of R. Okay, so we have to put everything over here. That's a lot of, the table over here is pretty big right here, guys. Okay, anyway, let's put it on the table. I'm sure that my table is not big enough, but we try to, okay? We try to. Okay, so we're gonna have, we have P, Q, R, negating a P, negating a Q, and negating of R. Then we have the conjunction. We have conjunction. Then we have a conjunction for negating. Oh, I think let me. So we have conjunction inside the bracket. That puts the conjunction inside the bracket. Then we have conjunction inside a parenthesis, which is right over here. Conjunction inside the bracket, which is the whole part right here. Oh, not conjunction, this is disjunction. Inside a parenthesis, and at the end we will have a conditional statement. Okay. Okay. Oh. Okay, so let's go. So we have two, four. Then we have 2, 4, 2. Excuse me. Then we have 4, 2, 2. Then 2, 4, 4. 4, 2, 4. Then we have 4, 4, 2. Then we have 4, 4, 4. Then we have negated P, 4, 4, 4. Let's use different color. Then we have 4, 4, 4, 2, 4, 2, 2, 2. Then negating Q, there will be 4, 4, 2, 4, 2, 4, 2, 4. Then negating R, there will be 4, 2, 4, 4, 2, 2, 4, 2. Then we're gonna do the conjunction. Oh, so we forgot this one too. We forgot this one. Oh man, we need to figure out this column also. It looks like we're missing 2 more columns. Yeah. So we need to figure out this. We need to have this column. Okay, let's do over here. Let's do over here. Oh man, I don't have enough space right here. Yeah. I guess I'm gonna put this one over here first. Because I think I'm gonna do this one first. P imply negating Q. Okay, then over here I do negating P imply negating R. Then we will have conjunction inside the bracket. Then we have this junction inside the parentheses. And finally, we have C. Okay, here you go. I hope that I can draw. Okay, so P implies negating Q, so P implies negating Q. So pass the course, but did not get the watch. Pass the course, but did not get the watch. So you will have 4. Okay, pass the course, but not getting the watch. Will be 4. This is 4. This is 2. This is 2 because did not pass the course, did not get the watch. This 2. This also 2. This is 2 because did not pass the course, but promise still keep. This is 2. Alright. Negating P and negating R did not pass the course, did not get the watch. 2. Still get a watch. 2. 2. 4. Did not get a watch. Did not pass the course, but still get the watch. 2. 2. Pass the course, but did not get the watch. Promise broken. 4. This is 2. Okay. Now we're gonna do the conjunction between these two. Okay. Conjunction is N. No TV but laptop 4. No TV but laptop 4. Okay. You know what? Let me move a little bit. Hopefully we can move a little bit higher. Okay. Okay. Got TV and laptop 2. 4. TV laptop 2. TV laptop 2. 4. 2. Alright, now we do disjunction between this and this. Then this one should be, oops, I'm sorry. This one should be, oh my god, I don't have enough space. This one should be negating the P, negating R. So they don't have back to the degree of 5 year 4. 2. 2. Right here, I'm sorry, Q and R. So there is also 2. It's 4. It's 2. It's 2. It's 2. It's 2. Okay. Then at the end, okay, we're gonna have this 2 because did not pass the course, did not get a watch. Did not pass the course, still get the watch. 2. 2. 2. 2. 2. 4. Oh, this is still 2. I'm sorry. It's still 2. 2. Okay, it's still 2 right here. And it's still 2 right here. Okay. So look like we have tautology right here. See that? Let me use different color. Let me draw that again. Let me erase that, put it in red color. So this is 2, 2, 2, 2, 2, 2, 2, 2. We have tautology. So now we know that the argument over here is valid. Valid. Here you go. Okay. So remember what I say, okay? If they give you the problem and problem is this fall into one of the standard form, then we know it's valid or invalid right away. If it is not, it does not fall into our standard form, then we gotta use the table. Okay, that's the only option over here. Okay, so in the last example, okay, we're gonna check the argument if it is valid or invalid for the case when we have three premises at the same time. So you see that in the so far on the argument we have contain only two premises. Okay, we have only two premises. Now what if we have three premises? Oh, actually this one have three premises already. Okay, now what if we have the one Q let me see, we have three premises over here. We have one, two, two premises. Look like this one, we have only two premises too. So we have P, Q. Okay, so this one we have premises, second premises. Yeah, this one so far we did only two premises. Okay, so even this one we have only two premises. Now let's do the case when we have three premises. Okay. Okay. So let's load the problem. Okay. So you see that three premises. So we have the first one right over here. Okay. So this is the first premises here. Premise, and this is the second one, second premise, and this is the third one. Okay, for this case we must use the true false table, right? Because we don't have the valid or invalid, we don't have the standard form of valid argument for three premises. So for three premise, so we have to use three premise, this true table for three premise. Okay. So again we have to create a symbolic argument. Okay, so P represent what? My cell phone company is Verizon. Okay, is Verizon. Q, I can call you free of charge. I can call you free of charge. And the third one is I can send you a text message. Okay. Okay, so we have three simple statements like that. So the first premises is the conditional statement. So we have Q, P imply Q. Then I have a Q imply not imply, it's or. So Q or R. Then we have R or P. Okay. Or P. Then finally, therefore, my cell phone. So we have P right here. So that is the symbolic argument. Then we go ahead and create the conditional statement for this argument. So the conditional statement we have over here, let's use the C. So we're gonna have P imply Q. We'll have intersection I mean we have conjunction for between the premise. So conjunction with Q or R, and conjunction with R or P. Okay, the whole thing over here is conditional statement with P. Okay, so we will have two conjunction statement like this. We can do the first one, or we can do the last two. Then we do the intersection with the first, or we do the first two intersection, then we intersect the last one. It doesn't matter. Okay, so we can do anything you want. Okay, the first two or this, or the first intersect with the last two. Okay, so let's load the true false table first. Okay, of course I'm sure that my true false table here is not enough. Okay, we need more than that, but anyway, we try to get more column by just go ahead and draw over here. So we have P, Q, R, then we have P imply Q, then Q or R, R or P. Then we have then we're gonna have this one. Okay, we have this one over here. So I'm gonna call this I'm gonna call the group right over here. I'm gonna call that I'm gonna call this is this conjunction conditional. So this I'm gonna call this intersection. I'm gonna call this I. Okay, so I'm gonna have I here. Okay, I have I here. Then I call the whole bracket over here is notated something like this. Like this. Okay, or you can draw like this if you want to. You draw this and parentheses, this parentheses, this. Oh, I don't have enough space, so I guess I just put this and this. Okay, for the bracket. Then finally we have for C. Okay, for C. Let's move this a little bit bigger, up higher. Okay, let me erase that. PQR. Okay, so try to be really perfect over here. So this is P, Q, Q, union R, R, union P, and this is I, and finally we have C. Okay, column C. Okay, so we're gonna have chew, for. We've been doing this for many times already, right? Chew for, chew for, chew for, for, chew for, chew for. Okay, P imply Q, P imply Q. Pass the course by your watch. Okay, pass the course by your watch too. Pass the course by your watch too. Pass the course, did not buy your watch. 4. Did not but still buy your watch from his keep. 2. 4. 2. Did not pass the course, did not buy you the watch. 2. 2. Okay, now between Q and R, so there's 2. 4. 2. 2. 2. Pass the course, did not buy you watch. 4. 2. 2. Okay. In between R and P. Okay. R and P, we will have R and P will be 2. Did not pass the still by your watch. 2. 4. Did not 2. 2. Pass the card but did not buy you the watch. 4. 2. Okay. Then we do I. I is oh sorry, this is not this is between I. This is between I. I'm sorry. This one is the whole bracket, so it's between I and I intersect with the parenthesis. Okay. So I is the intersection between PQ and QR. So laptop, computer, laptop, computer, laptop, computer, laptop. So this one should be 2. 4, no laptop, no TV. 4. 2, no TV. 4, no laptop. 4, no. It's 2. It's 2. And we're gonna do this with this. So we're gonna do different color right here. So we're gonna do let me see what color should I use over here. I'm gonna do this. So this would appear so 2. So no laptop, no TV. 4. No TV. Remember the again. Think about the example I give you. TV but no laptop. 4. TV, no laptop, no TV but laptop. 4. 4. 4. 2. Okay. Okay. Then C. C is this bracket with P. Pass the course, buy you the watch. 2. Did not pass the course, still buy your watch. 2. Did not pass the course, still buy your watch. 2. Did not pass the course, did not buy you the watch. 2. Did not pass the course, still buy you the watch. 2. 2. 2. Passed the course but did not buy you a watch. 4. Ooh. Then now look like that one of them. You see that one of them is 4. So it means what? It means this is not tautology. If it is not tautology, so what we have? It means that this is not valid argument. Is not valid. There you go. Okay. All right. So again, I'm gonna stop right here because I think I have enough example already. If you watch the video and if you don't understand anything, please let me know. Um, yeah, I mean, again, you must know the example I give you. Otherwise, you could be confused between the two of them right here. I'm telling you, it's hard to memorize. Also, you shouldn't memorize. Okay, you have to use the example I show you. That's a trick I show you. Okay, so okay, I'm gonna stop over here, and I'll see you in the next